Okay, one proof left for this theorem. We have to prove this, that for every sequence xn in the domain converging to x naught, that this sequence f of xn converges to f of x naught. And we're going to assume that f is continuous at x naught. So I'll say, I probably wouldn't have to say this, but let's go ahead and say suppose that's true. Suppose f is continuous at x naught. And for 3, we need a sequence, so let's get such a sequence. And let x in be a sequence in D, capital D, that converges to x. So converging to x naught. Okay, so we now need to prove that a sequence converges. So I'm going to need an epsilon to prove that a sequence converges. Let epsilon greater than 0 be given. By part 1, since f is continuous, by part 1, there is a delta. There exists a delta greater than 0, such that, and I think I'm going to continue on this line, such that x in the domain and x minus x naught less than delta implies that f of x minus f of x naught is less than epsilon. That's just using the definition of number 1, what it means to be continuous at x naught. So we know that that delta exists, that delta right there. And since x in converges to x naught, we have a convergent sequence, we can let capital N in the natural numbers be such that n greater than or equal to capital N implies that xn minus x naught is less than that same delta. That's just the definition, using the definition of a convergent sequence.